All right, we will start our fraction operations unit off with adding and subtracting fractions. I put adding and subtracting fractions together because the procedure for what you do is basically the same thing. These will be good points to write down because these will be what I'm looking for and what I'm expecting when you're adding and subtracting fractions. Very first thing, we have to have common denominators. We have to have the same bottom number before we can add or subtract. You'll see why in a minute when I show you some pictures, but it's hard to add or subtract fractions together that have different size pieces. It just doesn't work. Second thing, we got to add or subtract the top number or the numerator. We keep the bottom number or the denominator the same, and then at the very end when we're doing our answer, if you can reduce it, do it. If you can't, leave it the same. If you end up with an improper fraction, we're going to change those to mixed numbers. Having your answer as a mixed number as opposed to an improper fraction is much easier because then whoever's looking at your answer or whoever's interpreting your answer can automatically tell like how many holes you have, which is nice, how many whole pieces that you have, instead of just looking at how many parts there are. Okay, so please keep that in mind. 3/8 plus 1/8. This problem will be incredibly easy, but I want to show you how these work before we get into the tougher stuff here. The reason that this problem is easy is because our pieces are split into the same size. They're both into eighths. So when we think back to that very first board I showed you, we need to have common denominators. This already has common denominators, so we don't need to worry about that. Okay. Now our question basically is, how many eighths, since we have the same size pieces, how many eighths do we have altogether? And all I said was you had to do was add the tops and keep the bottom. So actually, how many eighths do we have? We've got 4/8. And we can show that pretty easy with the picture. If we add this one onto this picture over here, let's say we take this one and put it right here. Now if I count up what we have, I've got 8 pieces and I've got 1, 2, 3, 4, which is what I have over here. It was really easy to do this because our bottom numbers are the same, and they're not always going to be the same, or usually they're not going to be the same. So this is a good technique, and we'll talk about how that works. Now, the other two things I said was your answer. If you can reduce it, we're going to do it. And I can reduce 4/8. And this is what I'll be expecting from you. Will not be right unless you reduce it, if possible. So 4/8, I could probably just divide it by 4, and I get 1/2. 1/2 is my answer. And if you look at the picture, this is basically 1/2. If I take off these lines here, and then I don't worry about these lines in between, and I color in the same amount of space, that's essentially 1/2, which is what we have here. The other thing that bottom part on the first board said was, we're going to change it to a mixed number if possible. Okay? This cannot be changed to a mixed number. A mixed number would imply that my fraction is more than one whole. That's the only way you can get a mixed number, is if your fraction is more than one whole, or if it's an improper fraction. Improper fraction is more than one whole. This is less than one whole, so we keep it exactly how it is. All right, this problem is going to be particularly tough to deal with because we've got different size pieces. I can't just move one of these pieces over here and stick it in there because they're not the same size. They don't fit right. So we need to get our denominator to be exactly the same. And if our denominator is the same, then we're not going to have any problems. It's going to be really easy to add together. And this is where knowing how to find a common denominator comes into play. So we need to find a common denominator between 8 and 6 to make this easy. So what I will do is, underneath, this is what I always like to do, and I think it works out well. I'll have the original fractions on top and then the new ones on the bottom here. And I'm going to do this twice to show you how we can do it a different way. A common denominator between 8 and 6. Again, remember, if you can't come up with one, we can list 8s. So I could go 8, 16, 24, and I could list 6s, 6, 12, 18, 24, until I find a match. My first match is 24, so I'm going to use 24. So my bottom numbers are going to be 24. Okay? And we're still adding these together. Now, when we find common denominators, I have to multiply the bottoms by what it would take to get our new bottom numbers. So 8 times 3 is 24, and 6 times 4 is 24. Okay. Now, it was just a coincidence in this one that the top number's 3 and the top number's 4. That doesn't usually happen. But remember, we do have to multiply the top by the same thing. So I am going to multiply the top by 3 also. And I'm going to multiply the top of this one by 4. So my new fractions that I'm going to add together, I've got 9 24ths, and I've got 16 24ths. Okay? 9 24ths is equal to 3/8. 16 24ths is equal to 4/6. So we're doing the same problem, just with the same size pieces. So now I just need to add these together. My question is, how many 24ths do I have all together? So I instantly know that my bottom number is going to be 24. Okay. Now I just have to add 16 and 9. 16 and 9, let's see, 16 plus 4 is 20, so that would give me 5 more. That's 25 24ths. Okay. This is my answer, almost. We need to go through the process to see if I need to reduce it or if I can change it to a mixed number. I cannot reduce this. There's nothing that goes into 25 and 24, so that's good on that front. But I look at this, and my top number is bigger than my bottom number. If that happens, this is more than one whole, so I should be able to change this to a mixed number. So basically, I'm deciding how many 24 is going to 25, or I can do a division problem if you're used to doing that. I know that 24 goes into 25 one time, and we're keeping the bottom number. My leftover amount would be 1, because if 24 goes into 25 once, my remainder is going to be 1. So my answer is going to be 1 and 1/24. Now quickly, I want to show you this problem in another way, just in case you didn't come up with 24 as a bottom number, but it should come out to be the same thing. So if I have 3/8 and I have 4/6, like my original problem over here, I'm going to do new bottom numbers. And let's say you couldn't think of anything, so you just did 8 times 6 and you got 48. Okay, that's a way to do it too. And if we would have kept this list going, we could have done 48 also. If that's the first one you think of, then that's fine. So I'm going to put 48s here. Okay, 8 times 6 is 48. 6 times 8 is 48. So now remember, I have to multiply the top by the same thing. So that's going to be times 6, and that's going to be times 8. 3 times 6 is 18. Looks like 4 times 8 is 32. Now I've got the same thing, but my question now is, how many 48ths do I have? Okay, so my answer is going to be bottom number 48, top number, let me write that a little lower so you can see it, 48, top number 18 plus 32, 32, 42, 50. Okay, now I would start with reducing it if I can, and I should be able to. I can divide both of these by 2, I know it. If I divide both of these by 2, divide by 2 and divide by 2, I'm going to get 25 24ths. Oh, where is that? Where have we seen that at before? Right over here. Okay, and of course, 25 24ths still turns into 1 and 1/24. All right, we're going to do subtraction this time, but it's not any different. It's exactly the same. We still have to have the same bottom number. We can't just subtract how we have it. I mean, if you think about it, if I drew a picture with this here, if my bottom numbers were the same, all I would have to do is start with this picture over here, see how much this was, and take that many off of it. But since my bottom numbers are not the same, I can't do that, but I will eventually be able to do that. So let's try this out here. We need common denominators. Okay? And the smaller you can think of, the better. The less work. Basically what it comes down to is the smaller common denominator you can find, the less work you have to do at the end, the less reducing you'll have to do at the end. So I'm going to start with the smallest one I can think of on this one. If I list out 5 and I list out 10, my first match is going to be 10. Okay? So I'm going to put 10s down here. Okay? This would, of course, to get 10, be times 2. Well, what would this be to get 10? That's just going to stay the same because that would actually be times 1. Okay, I have to multiply the top by the same thing. 5 times 2, so we got to times the top by 2. That's going to be 8/10. Subtract. Times the top by the same thing, 2. Now I've got 8/10 minus 2/10. So my total is, after I do the subtraction, how many tenths do I have left is basically what we're asking here. Okay, well, 8 minus 2 is 6. Our answer is 6/10, almost. We should be able to reduce this down. If I divide by 2 and divide by 2, I'm going to get 3 and I'm going to get 5. So my answer is going to be 3/5. And if you think about it, after I have common denominators, let's say, and I could draw this out, this wouldn't be too hard to do. Let's say I have a picture with 8/10, and I'll try to do this as best as I can here. I should have done this beforehand, but that's okay. 1, 2, 3, 4, 5. Let's fill in an 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 filled in out of 10. 8/10 minus 2/10, so if I take away 2/10, I'm still left with 1, 2, 3, 4, 5, 6/10, which is what my answer was. Now I just needed to reduce it. Let's go over here to the same problem. I want to show you we get the same answer, but if you use the different denominator that still went, 5 and 10 still went into it, you're okay. 5 and 10. I could use 20. That would be okay. 20 wouldn't be so bad. Okay, that would be a times 4 to get 20, and this would be a times 2 to get 20. So I need to multiply the top number by the same thing. So I've got a times 4 here. That still is times 2 because we have to multiply the top by what we multiplied the bottom with. 4 times 4 is 16. 2 times 2 is 4. So now my question is, how many 20ths will I have left if I do 16 minus 4? And of course, 16 minus 4 is 12. Okay, we don't have the same answer that we had over here yet, but we should in just mere moments here. If I do 20 and 12, I know I can divide those by 4 to reduce. Okay, that's going to be 3, and that's going to be 5, and there's my answer. Now, I could not change this into a mixed number. There's no way possible, because my fraction is less than 1 whole. A mixed number is something that has a whole number on it. These are both less than 1 whole, so we can't change into mixed numbers. These are our answers for the problems.